So here we go. I've launched the recorder. I'm going to launch idle to write myself a program. You can do this if you want. You don't have to. IDLE from the search box. And by the way, we'll do the MindTap book creation on Tuesday. So let's put that off until then. Am I going to write my program here? Well, conceivably I could. I've already told you that the shell lets you add interactive commands. The problem with the shell is that if you make a mistake, you can't go back and edit it again because it's already done that command. It's done with it. It did it immediately. It's like I told you how to cook the burger. I told you to throw it on, to throw the meat on the fire, but I forgot to tell you to turn the stove on or whatever. I can't just retroactively go back in time and have you turn the stove on first. So what I ought to do is I ought to create a recipe, a series of steps, give it to you, and then you do them all at one time. So I'm going to create the recipe right now. Fancy word for the recipe is the algorithm. Algorithm is just a series of steps to accomplish a problem. Well, we're going to accomplish a problem. We're going to, print out a message a certain number of times. So I'm going to do new file, and I'm going to do file save as, and I'll probably remind you every single time we do this, don't save your code into the Python 37 directory. Instead, create your own directory somewhere and save it there. So I created a directory off the desktop. I dragged it onto my quick access to make it easy to get a hold of, and I'm going to call it lecture B. All right, what do I like to do at the top? I like to add a comment block, and when I say I like to, I want you to. So, I'm going to put my name. You ought to put your own name. What is this? This is CIT1203. And what are we going to do first? We could put, that this is lecture B, but we could already tell that from the file name. And, the today's date, whatever that is. I think it's the 23rd. Yeah.
Thompson?
Yes, sir.
11/13.
We're not. I keep doing that on you. Y'all are going to go forward in time and get to 12:03. Alrighty. I don't know what's wrong with my brain. It's because I have an 11 o'clock class on Monday and Wednesdays. That's 11:13. That's the problem. Alright, so let's write a function that does something. How about it just prints 3 lines in a row? Now, in this language, the way you write a function is you use a keyword, DEF. And these keywords work the same way that the variables do as far as the compiler is concerned. When it sees that keyword, it knows to create something in memory. Get a memory address and assign something to it in order so that when it sees this function name again, it knows what to do. We're going to call this function sing. And so the way you define a function in this language is to use that keyword. You give the function a name, just like if I was writing a recipe, I'd give it a name, right? So like, Mama's lasagna, that's the name of the recipe. Sing is the name of this function. And when you create a function, you put parentheses there, and sometimes you put things between the parentheses, variables, like that height and width that got passed in there. This time, nah. All right, so what are we going to sing? I don't know. Maybe 2 lines of a rock song. Nobody listens to rock anymore. What do these kids listen to anymore? So print, I love rock and roll, end quote, in parentheses. Print, parentheses, quote, put another dime in the jukebox, baby. There we go. When I turn on the radio, what it sounds like to me is that somebody has taken 3 seconds of melody and looped it 100 times in a row or 1,000 times in a row with some singing on top of it. And that's cool for rap, but it doesn't seem right for other kinds of music. Now we're going to call our function, right? Sing. We don't put a colon there because we put sing with a colon up here to define the function. We're not defining it, so we're not going to put a colon there. This had to be back-tabbed against the margin because it's the end of the function. Just like when we did a loop, we back-tabbed to end our loop. Here we're doing the end of our function.
Wait, do we need to return something?
Not in this particular case, but it never hurts to put a return statement. but there's nothing to return because we didn't calculate anything. But just like you mentioned, we can note that the function is going to be done now. If we had left that out, it would know it was done by when it hit the unindented line. I don't mind putting it there. Makes it really clear that that's the end of the function. So when I run it now, what it does, starting from the top line, it says, oh, I can ignore that. That's just a comment. I can ignore that. I can ignore that. I can ignore that. Aha, here's something I got to do. It's a def, it's a define, so I'm going to create this function, but I'm not going to call it, right? This writes the recipe, right? But this actually invokes the recipe, right? I write the recipe here that tells you how to cook laundry. Don't cook laundry. Lasagna. And then down here, we're going to say, okay, I want some lasagna. Here we go. So we're going to sing. Let's run it. And it did exactly what we did. But why did we put that in a function? We could have just put these statements right down here, so that we can invoke it multiple times, right? So sing, question mark, in, question mark, sing, question mark, in, question mark, like that. Now what's it going to do? Each time it hits this word and sees a question mark after it, it's going to go, oh, I know that's a function. I better go and find the function and do what's in it, and then come back. So it writes those 2 lines out, returns, and then it's ready to do it again, and then do it again. So we're going to see 6 lines.
In the shell.
Yep, 6 lines in the shell. Boom, boom, boom. And just to kind of, I don't know, print, parentheses, quote, one more time, exclamation mark, end quote, in parentheses. And then sing, parentheses, in parentheses. Right? And it did it. Right? I love rock and roll, put another dime. I love, put another. I love, put another. And then it said one more time, right? And then I love, put another. So let's go from here. All right, so that's about enough of this. Let's get back to our section. Modules. These are in the wrong order. I like modules to be up at top. And we should have some PowerPoints. Now, as you take classes, you will realize that usually what Chapter 1 is what is a computer, right? That's usually what Chapter 1 of every programming book is. And so you get to read over and over what a computer is. But there's some other good information in here as well. But you're going to see me scroll through the PowerPoint rather quickly for that purpose. I mean, for that reason. We know what an output device is, right? It's something that, like, you send something to a printer. That's output. You've heard that term. You know what input is. Input is typing on a keyboard or tapping on a touch screen or recording from a microphone. Describe the basic features of an algorithm. Explain how hardware and software collaborate. Well, maybe we won't do that. Give a brief history of computing. I could make you read that, but compose and run a simple Python program. To me, this is the meat. This is the meat. So let's go look down here. So computer science focuses on a broad set of interrelated ideas. Algorithms and information processing. Algorithms are the recipes that we create to tell the computer what to do. Why is it called an algorithm rather than a program? Because you could design an algorithm and then give it to a different programmer to write in a different programming language. Just like the recipe is not the omelet, the recipe is how to make the omelet. But you might have to translate that recipe into a language, right, in order for that cook to understand it. Anyways, so the steps for subtracting 2 numbers. You write down the numbers with the larger number above the smaller numbers. And then starting with the rightmost column of digits, you do some subtraction. What's the difference? You had 7 and 3 here. 7 minus 3 is 4. And then if you had to, carry over something minus, you could do that. So you start with the rightmost column, you do the subtraction, you come back to the next column, you do the subtraction, you do the next column, you do the subtraction. That's the algorithm. The sequence of steps that describes each of those computational processes is called an algorithm. So what is an algorithm? It's got a finite number of instructions. I don't know why they feel the need to say that, because if it had an infinite number of instructions, would it fit in computer RAM? Right, no. Finite number of instructions. We wrote a program right here that had, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 instructions, ignoring the comments because that's not part of the algorithm. Comments just describe it. It's like the painting, on top of the recipe or writing on the front of it. Each individual instruction is well defined. What does that mean? Well defined means it has to be very precise. If I was going to tell a machine how to cook an omelet to be prepackaged, I'd have to be a lot more precise than just telling a human, okay, cook for 3 minutes over an open flame, right? I can tell you that because you're a genius. You know how to do all that stuff, but a machine does not. A machine has to be very precise, squirt this, number of milligrams of eggs into this tube and, roll that over to the heater and turn the heat. Right, it's got to follow very specific instructions. So, have to be very precise. The whole thing's got to describe a process that eventually ends. Your algorithm needs to end. It better not be an infinite loop, or else the algorithm will never end, right? Like the shampoo bottle. Wash, rinse, repeat. Great algorithm. I don't know why we repeat. I usually don't wash my hair twice. But it never says when to stop, right? So that's not an algorithm. An algorithm would need to have some third step which says, if done, stop, right? Or if hair is clean, stop. Then it could be an algorithm, right? Wash your hair, rinse it. If your hair is clean enough, stop. Otherwise, repeat. Or repeat until washed. Repeat until clean. Sometimes I don't even wash my hair. So I might write that algorithm something like this. While hair equals dirty, wash, rinse, right? And it would keep doing that while my hair was dirty. So it's got to halt after a certain point. And it's got to solve a problem. Otherwise, you're not going to really write an algorithm, even if the problem is just to amuse yourself, right? People write games in probably the most profitable form of software out there because it entertains you, but that's the problem, right? We're going to make define our problem as, some kind of entertaining game that will engage the customer and make them want to keep playing it. So information is commonly referred to as data. We're supposed to pronounce it data, I think. I don't know which way we're supposed to pronounce it. I don't really care. I know that the Star Trek character is defined, one way, and supposedly the correct term is the other, and I forget. In carrying out the instructions of an algorithm, a computing agent manipulates information. So, it's got to get some input, it's got to transform information according to well-defined rules and produce output. Well, our program didn't have any input. We didn't ask the user anything. We didn't actually transform any information. But that's because we wrote a really, really short little demo program that all it did is print some messages. Normally, your program is going to be structured more like this. And let's write a second little program. And if you didn't get the first one in, that's okay. Just start at the top. Right? We need some input. Let's ask the user what the height is of that rectangle. H for height equals input parentheses quote, what is the height, question mark, end quote, in parentheses. If you've taken C in Java, you know that once you get some input, you can store it in a variable of a specific type, like an integer or a float or a string, and then that variable never changes its type. Not in this language. In this language, you can convert a variable from one type to another with reckless abandon. So what we get here is a string, which is a series of characters, like typed in from a keyboard. That's all string means, is a series of characters that you could type in from a keyboard. But we got to convert it to a number, right? I couldn't multiply something I typed in from the keyboard. Instead, it has to be numbered to do math. So h is equal to, and we're going to convert it to a number using this function. What does float mean? Well, there's two kinds of numbers, effectively, that computers deal with. Integers, which are whole numbers, and floats, which have a decimal, floating point. You may have heard that term because a decimal can be in different places. All right. And so h equals float parentheses h end parentheses. And don't worry if this is not totally making sense yet. For some of y'all, it's review. For others, it's brand new and it may not click the first time you see it. We haven't read about it in the book. I like to show you stuff on the screen before you hit it in the book so that when you read it in the book, it makes sense. Because honestly, not everybody reads the book. And so if I relied upon it working the other way, it might not work. All right, so we've got some input. What is the height? You know what? I'm getting bored, so I'm not going to write the next part of the program, which would be to ask for the width. Instead, I'm just going to cube it, right? Or square. We're going to calculate the area of a square, which is just height times height, right? So let's do some calculation. The area of a square equals height times height. And when I say times, I mean the asterisk. H equals h asterisk h.
Wait, can you use square in Python?
Yes, you can. You can do star star 2. And if you want to cube it, you do star star 3. So I'm going to add a comment here as to what in the heck we're doing. The hashtag begins the comment, calculate area. And remember, you get positive credit, you get full credit for attending a class and turning in something even if it doesn't work. So don't sweat it. You don't even have to type in anything if that's not your thing. All right, now let's print the result, because why did we calculate something if we're not going to tell the user the result, right? We ask them some questions and then that's it? Nah, they want something to happen. Print, parentheses, quote, area equals, end quote, comma. The comma has to be outside of the quotes. And you don't have to put spaces like I do. I just do that to make it easier to read. A, end parentheses. So strictly speaking, this isn't an algorithm. This is an actual program. If I was going to write it as an algorithm, it would look like this. And to kind of reinforce the idea that you don't have to write this, I'm just going to put it in Notepad, right? It ought to say something like input, height, area equals, or sometimes people do fancy little things like that, height times height, and then output area, right, or A. That was my variable, right? Don't type that because it's not part of the program. This is the algorithm. It's very generic. Some people call it pseudocode. It's very generic so that you could write it in C++ or Java or Python or JavaScript or whatever language you wanted to. Let's get rid of that. And let's run it. It's going to do our singing first, but then it'll ask us what the height is. According to our textbook, PowerPoint, that did some input, some transform. Usually I just call that calculation. Transform sounds spooky. And then produces output. So 3 steps. Get the input. I'm going to call it calculation, but the textbook calls it transform. Like a Michael Bay movie. And then, calculate. We've already got that comment here, calculate. I'm not going to use the word transform again. And I'm not going to put it on a quiz. And then lastly, output. So I added some comments here. At a certain point, I'll tell you that you have to comment your code well or you're going to get reduced credit. In the beginning, I don't consider that the most important thing. Some other teacher might yell at me for that, but I don't care. Let's go run it and see. It ran. And then it asks me, what is the height? I better type something in. It's just sitting there. And the height of this square is 10. And the area equals 100. So we didn't see it do this calculation, but we saw the results. So if you want to type notes into one of these programs and you want to type in a whole bunch of lines of notes, a whole bunch of comments rather than just one, don't type this. You C++ or Java programmers remember that. In this language, you do that. Quote, quote, quote. Or single apostrophes if you like apostrophes rather than quotes, right? I like double quotes for some reason, so I'm going to run with that. 3 double quotes. All right, so an algorithm, I'm going to define it as a series of steps to solve a problem. I'm not going to get into the fact that it has to be a finite statement, right, whatever. This is my definition. It's better in the book because it's shorter. And then our algorithms, programs, usually follow, especially in the beginning, a specific pattern. Which follow a pattern, which is get your input, calculate, and output. Now these are the easiest programs that we're going to write. Ones that just get some input, do a single calculation to it, and do some output, right? Because obviously programming can get a lot more complex than that. The input might be saved to a file, right? And the output, the calculations might be, lengthy, and the output might be complex to make a nice pretty report. And maybe it's got to do some input over and over, right? They get more complicated. But in the beginning, these are what our algorithms are going to do. Now I'm going to end my little section of notes with 3 more quotes. I know that I'm in notes because they're all green. So I'm going to do quote, quote, quote. And by the way, you don't have to type in the notes, just like you don't have to type in the program because I always upload it at the end of class. Not encouraging you to not. Just saying. Don't you hate that phrase, just saying, and yet I still say it. Alrighty, did anybody not get your program to calculate the area of a square and print it out? I better do another walk around, see if there's syntax errors going on. And although you couldn't see it since I had to scroll off the bottom of the screen, I already mentioned that you end your comments with 3 quotes. So there's 2 kinds of comments in this and a lot of languages. There are single line comments. In this language they're marked by the hash. And there are multi-line comments. Now I could have just put a pound sign in front of every line, right? But save time just to do, the 3 quotes. So, as our technology gets better, people are getting better and better, programs are getting better and better, I should say, at figuring out how to store data to represent images, because a picture, right, is just a series of numbers representing this first little teeny tiny picture element, pixel. It has this amount of red and this amount of green and this amount of blue in it, right? And then the next pixel has a different amount. The next pixel has a different amount. It's just a series of numbers. Same for a music file, right? Something analyzes it and figures out that in this millisecond the volume is this and the pitch is that, and at this millisecond the volume is this and the pitch is that. It's just a series of numbers. And it's funny, like, you get a good music song and it's about 8 megabytes long. And if y'all are of a certain age, you probably use floppy disks, maybe way back when. A floppy disk held like at most less than 2 megabytes. It would take 4 floppies at least to hold that one Beyonce song, right? Kind of amazing how things go. Yes, sir?
you can get multiple floppy disk to install Windows.
Yeah, really. Yeah. Used to be that if you were going to install an operating system, like DOS, it'd take 4 floppies, and if you were going to install Windows, it'd take 18 or 20. It was ridiculous. So the algorithms that describe information processing can also be represented as information. Well, what does that mean? Well, this is information as well. It's got to be stored on the computer as well. I could figure out how it is stored. I'm just going to go to a website called hexed.it. I'm not really sure it's in Italy, but it made for a cute little thing because it's supposed to say hexedit. And with hexedit, I can do open, file. I can go and grab my file, go and find lecture B. And this is how my program is stored on the disk drive. It's just a series of numbers. Each number corresponds to a letter, a character of my file. Remember I put a hashtag? Well, a 23 represents a hash. A 4A, well, what the heck kind of number is that? We're going to ignore the fact, but it is a number. It's a J, and an E is a 65, and an F is a 66, because an F is one more than an E, and so on. So if I wanted to, I could edit my file directly from this thing just by changing a number. What if my name was JFFF rather than JEFF? Well, I could change that E to an F and save it. And then go and edit that. And there, right? I've changed my data. I changed the information. Now, I didn't actually change the program, really. I just changed a comment, so it doesn't behave any differently, but I could have, You could actually write a whole program just doing that. Back in the early 70s, before personal computers were a thing, you'd look in the back of Popular Mechanics or whatever, and you'd see an ad for an Altair or something like that. And it'd be a kit that you'd buy and you'd solder together. And if you look at an Altair, it probably cost $500 or $600, which is a lot of money back then. It didn't have a keyboard, didn't have a monitor. All it had was a row of switches. And if you were going to enter your program, you would set all the switches, and then you would hit another switch, which is like the enter key. And that saved a single letter to memory. Then you'd set the switches differently, and you'd hit the enter key, and that would save the next letter. You wrote an entire program like that without even getting to see the output, right? And then you ran it, and what did it do? It lit up lights on it. Okay, but first personal computer, right? And then sure, people invented monitors or ways to hook it up to your television and ways to add keyboards to it to make it more functional. But before the Apples and the Commodores and stuff like that, all the people who invented those probably bought one of these and then wanted to make it better.
What exactly are the real life applications for that?
Absolutely none. It's a learning tool. It's a learning tool. Yeah. Oh, well, I say that, but if you were serious enough about writing some program and you wanted to write some program that calculate the value of pi out to 10 decimals or whatever, and you were good enough at flipping switches in order to do it all accurately, then you could do some real calculation on it. But mostly it was a toy for people to learn what a computer was, and then it wouldn't do much good until you wound up getting a keyboard and a monitor to hook up, until those things were invented. Not a monitor, but a hookup to your television. Fortunately, we don't have to do all that anymore.
And programming back then is you had to use sheets and stuff like that.
Yeah, people used to fill out punch cards. Fortunately, there was a punch card reader in the college that I went to, but I didn't have to use it, thank goodness. Because you'd punch all the cards and then you'd hand it to somebody else and they'd feed those cards into the computer, and if you made a mistake, then you'd have to go through all your punch cards and try to figure out what the mistake was. So a modern computer system consists of hardware and software. What's the hardware? It's the part you can touch. What's the software? It's the information stored on it. I told you I was going to skip this stuff, and I am. Computer memory, I showed it as being numbers, but it's actually ultimately just zeros and ones, where a 1 is the presence of some kind of electrical or magnetic charge, or in a 0 is the absence of that of that electrical or magnetic charge, right? And then these can be interpreted as numbers. Not going to talk about how that happens right now. So a program stored in computer memory must be represented in binary digits, or machine code. When it's stored on the file, it's that one sequence of digits. But then when it's actually got to run and it gets loaded into memory, and after the compiler works on it, it's a series of machine language instructions, which are things like that read, write, copy, right? When I created a little vocabulary of things. We're just going to skip that page. We're going to skip that one. So we use a text editor, type, to save our program. When we run it, several steps happen. A translator runs. Compiler runs. Hand it over there. Cool, thanks. Wait, you've already done it? Did I already hand it to you? Yeah, so we're done. Cool deal. How did I get a different pen than I started with? Whose pen is this? Oh, it transformed. We did some data transformation. All right. Thanks. I kept my pen. All right, so pencil. We type in our program, we save it. When we run it, the compiler reads the file and tries to turn it into machine language, and if it fails, it kicks out a syntax error. That's just because I made a mistake in typing. I forgot to do that. So it reads it from the file, it tries to turn it into machine language, and it fails because there was a mistake in the code. Say there weren't any mistakes in the code. Then it goes to the runtime system, which means that runtime is while it's running, right? It starts running that machine language to get user input and either display another error message if some other kind of crash happened, ran out of disk space or something, divided by 0, or to display the output.
Same error.
Computers have been around for a long time. In this one, you would set all the dials, and then you'd turn a handle, and it would, and the dials would move in order to represent the, it's the same thing as a hand calculator nowadays, except very expensive, made out of brass or whatever. We're going to get through this. No, this is cool stuff. I'm fascinated by it, but not fascinated enough by it to make y'all talk about it. All right, so Python was invented by this guy. What is it? It's a high level. What does high level mean? High level means that you can use English words, right? Print, right? Things like that. Whereas a low level language is a series of instructions. Right, LDX for load into X, and WY for write into Y, right? It's very cryptic. So fortunately, we use a high-level language. If you ever take an assembler course, learn how to use assembly, you'll be using a low-level language. Python is interpreted, meaning that it's not all converted to machine language beforehand. If you download an executable, you don't get source code that you can look at, right? Instead, you get an exe, or you get an app file that you put on your phone. You don't get English text. And so then Python interprets that text every single time it runs it. You know, every single time I run this program, it's got to recreate the machine language for it. Whereas as a truly compiled program, the programmer converts it to an exe and then ships that out, and you never get to see all this stuff. And why would you want to do that? Because that makes the fastest possible program, because it's only needs to be compiled once. And also, if you're charging money for your program, you don't want people just to be able to copy paste and send it to somebody else. So when you launch idle, it opens the shell. To quit it, you select the close box. Cute for experimenting with short expressions or statements and consulting documentation, but you don't normally actually write a program in this shell. Instead, you launch a text editor. But now that we've written our program, we could actually run it from a terminal or command prompt. So if you dialed into somebody's machine, right, you know, as a system administrator, and you're running commands by hand, we could run these scripts. I ought to just be able to type in Python lectureb.py, and if it's configured correctly, it will run that program. It did, right? However, for the user to be able to do this, if you copied your program and emailed it to them, they'd have to have Python on their machine, because it is an interpreted language, meaning that each time it needs to run, it has to have the interpreter, the Python interpreter on it. Whereas if I turned it into an executable, a .exe, I just mail them the exe, and the email system would probably reject it. Ooh, dangerous attachment. But anyways, I give them the exe, and then they would be able to run that without Python. And that's a compiled language, a purely compiled language.
It's going to be like, ooh, dangerous.
Yeah, email systems try to stop us from giving each other viruses. So as mentioned, a program accepts input. In a terminal-based interactive program, that's the keyboard and the terminal display. These are called command line programs or text programs, right? Even though I'm not running it from a so-called command line, when I run it from within idle, it looks like it, right? Gives me a window with text and I type it into it. So we can call these command line programs. What's another kind of program? A graphical user interface program, right? Like this. This is a graphical user interface program. So is this, right? I don't have to type. I can drag things around. I can switch to programs, right? So there's graphical programs and then there's command line programs. And for the first half of the semester, we're probably going to be mostly doing command line programs because they're easier. The code required to do a graphical user interface is much, much more complicated, which is why they weren't invented first, right? The command lines were invented first. So the input function here, what does it do? It lets the user type in some keystrokes. So it kind of reaches through the computer to the keyboard, grabs those keystrokes, builds a string, which is just a series of information, and returns it to the program so that it can be stored in a variable. So when we typed in what is the height, and I typed in 10, right, the keyboard got that 10 and returned it and stored it there. But that wasn't a number yet. It was just a string, a series of keyboard presses. And then it had to be converted into a number. And I can kind of prove that, because what if I typed in Fred? Oh, come on. What is the height? Fred. Is that a number? No, it's not. But that's not going to cause this statement to fail, right? Because all that's doing is asking the keyboard for information. It's this statement. When it tries to convert it to a number, I should have even added a comment to that effect because it kind of looks alien at first, right? Convert to a number, right? That's what that step is. And that's a statement that's going to fail now because I typed Fred, and Fred is not a number. So let's go ahead and hit enter on it, and we'll see it crash. Boom. Right? Was it doing me? Could not convert string to float. Telling me fancy words saying that whatever was in that variable was not a floating point number. So it crashed and it told me the line number. And as I mentioned, we don't have line numbers down the side, but we can always move our cursor up and down, and in the lower corner does tell us the line number. And so I could figure out what was wrong with that statement. Honestly, there's nothing wrong with it. I gave it bad data. Garbage in, garbage out. We could write our program to accommodate bad data, to check for bad data and not crash, which is kind of, the sign of a professional programmer. However, that's more complicated, so we're not going to do that at first. So here they're showing doing it from the shell. And I wouldn't do it from the shell because this is like, 40 lines, 40 characters of typing, and if I made a mistake, I wouldn't be able to fix it. I'd have to type the whole thing in again or copy and paste or whatever. But same idea. If we ignore these arrows, then it would be a program. I could take these lines, and as long as there wasn't a mistake, and I see mistakes because PowerPoint turns your quotes into, wrong things. But let's try it. I'm just going to copy and paste that into the shell and see if it actually works. Usually the code that I copy from the PowerPoints does not work because it gets formatted with extra characters that it doesn't recognize. But let's try it. See that? It's got the opening quote and the closed quotes because Microsoft Office put those in there. All right, cool. Into the first number, 20. I could do that for the next one and the next one as well. I would have to fix the quotes for that as well. Enter the second number, 44. And then the print command, the sum is first plus second. This particular program didn't even bother calculating the sum before it printed it out, right? We did not say answer equals first plus second and then print answer. Instead, we waited until the print statement to do that math. That's okay, but I'd recommend not doing that. I would have stored it in a variable just like we did with our area. So we have a bunch of functions. I mean, way more than we see here, but we've seen a few. Print. That's a built-in function. One book I used called it a BIF, and a whole textbook was filled with references to BIF. Built-in function. Well, I'm not going to call it a BIF. But print, what does it do? Takes this stuff and displays it. Input, what does it do? It displays what's inside the quotes if you give it quotes and returns it. Float turns a string into a number that can have math done on it, and so does int. The difference is that an integer is a whole number, where a float is not. So the input statement kind of works two different ways. Let me show you the two ways it works. Let me start the shell again because that's getting hard to read when it's at the bottom of the screen. If I did this, input x, like that, it's going to display the x. If I say input with nothing between the quotes, it doesn't display anything. Yeah. Nothing wrong with that. Maybe that's what we want. Maybe we don't want something to be displayed before the user types something in. For example, you can split up the printing and the input. And I'll show you what I mean. I'm going to go to the very top of my program and do print, parentheses, quote, are you ready to rock, question mark, end quote, in parentheses. But we better tell them what we want them to type. Y/N, right? They're going to type in either yes or no. And then I'm going to get that input. RESP, that's too long, right? S equals input, parentheses, in parentheses. Right? This part's not going to display anything. That's okay because we displayed something on the line above it. Right? Are you ready to rock? Notice where the cursor is. The cursor is underneath this line. If we had done it like this instead, if I just copied this statement and pasted it like that, The first time it runs, the print statement causes it to go to the next line, and the input's waiting underneath it. Yes. Are you ready to rock? Okay, the second time, since it's all in one thing, the input statement did not go to the next line. It just kind of, it's your preference. Do you like typing underneath your questions or out to the right of the questions? If you like typing underneath your questions, you'd use a print followed by an input. If you like typing to the right of the question, then you would just use the input statement. I kind of like doing it like this. For one thing, it saves me a little bit of time, right? Because this is two steps, and this is just one step. I should have stored the result in a variable, although I did ignore it anyways, right? So there. These two things do the same thing. The only difference is that this did not go to the next line before waiting for input. So we can run Python files from within idle or from the operating system's command prompt. Python files end in .py, we know that. Running a script from idle allows you to create a complex program, test them, and then if you wanted to, you could save them in a program library to reuse or to share with others. Because you can be sure that a person who sits down to write a video game does not just start from scratch and write all of their own lines of code in order to display stuff on the screen and read input from a joystick and a mouse or a touch screen or whatever. Instead, they use libraries of code to handle that stuff, and then they can work 10 times faster, or 100 times, or 1,000 times faster than if they had to write all that stuff. Steps in interpreting a Python program. The Python code gets read and it runs through the syntax checker translator. If there's a problem, it kicks out an error message. Otherwise, it produces a stream of what's known as bytecode. We don't get to see the bytecode, who cares? Then the Python virtual machine kicks in if the code did not have any syntax errors, and it goes in and actually executes the bytecode. And if the user types in input, it gets it. If it crashes, displays an error message, displays output. Kind of the same picture as what we saw before, but with more Python-specific names. Are they running the AC in here, or is that my imagination? It's 50 degrees outside and I feel the AC. Programmers inevitably make typographical errors. Those are called syntax errors. The Python interpreter catches those. What do I mean by catching them? It's not like it's hoping to find them. It means that as it's turning it into bytecode, if it reaches a syntax error, it doesn't know what you meant, right? You misspelled something, or you forgot to tab it correctly, or whatever. It can't convert that to bytecode, and so it just has to throw up its hands and fail. So it halts execution. Length is not defined. Why is length not defined? Because we stored it in a variable called length with a G. And it's so easy to make these kind of syntax errors, right? They're just typos. You use a capital letter in one place and a lowercase in the other. You transpose two characters, right? And it's hard sometimes to see them. That's why I like to walk around and help y'all, because usually I can spot them real quick. But it's like when you're trying to edit your own paper, you don't see the mistakes because you just typed it. But if you hand it to a friend, they can point out, the misspelled words and stuff.
Just like Comp 2.
Yeah. Are we almost at the end of this? Did we do a whole thing? Yeah, I think we did. Fundamental ideas of computer science, the algorithm, information processing. Real computing agents can be constructed out of hardware devices. That's true. Languages such as Python are high level, meaning that they're written in English-like syntax. Pretty weird. If you think about, you were born in Saudi Arabia or China or something like that, and you want to learn to program, you have to learn English. You don't know what the word print means or the word input means or whatever. It's kind of weird in my mind. Very few languages are written, obviously languages that were invented in the Soviet Union are going to be written in Russian. But,
I was going to ask you a question about that.
Yeah.
Is it universal? In other words, what we're doing here, everybody in the world knows this stuff?
Every computer ought to be able to run it. Not everybody knows it, but yeah, every programmer who wants to learn it can learn it. And every computer that can run a Python interpreter can do it. And you can even get a Python interpreter like for your phones, so you could write your program and then copy it to your phone and then run it. Does that make sense?
Yeah, I was just
Yeah.
wondering, like, if I went to Germany, oh yeah,
Yep.
they're familiar with this, or
Yeah, there's absolutely. The guy who invented it, Guido Rossmann, I think he's Swedish, right?
Okay.
But just like German musicians will record in English to try to sell to a broader, the Scorpions or, whatever, French singers or whatever, they all sing in English to try to appeal to a larger market. The people who invent computer languages, even if they're not British or American, go ahead and make their languages in Britain in English. We are done with the chapter. Am I going to make you do a quiz over the chapter? I don't think so. I'm going to assign just an itty bitty little bit of homework. I'm not going to make it a programming assignment. Why? Because you may not have Python installed yet, although you're supposed to do that over the weekend, right? So what is our programming assignment going to be? I'm just going to tack it on to the bottom of here. All right, quote, quote, quote. Homework. Use Google or whatever to find the formulas for these problems. The area of a sphere, the volume of a sphere, the volume or the area of a cylinder, and the volume of a cylinder. That's all you have to do, and you can type it up in Word or a Python file or text or whatever. Don't write a program just for it, just find it. I'll give you the first one, right, and then you're going to look up the next ones. Well, I don't know what the area of a sphere is, so I'm going to go and Google it. This homework will probably take you 2 minutes doing what I'm just about to do. Area of a sphere. And Google tells me, woohoo. Now don't just copy and paste that, because Python, if you were actually writing a program, wouldn't know what that symbol is, but you know that means pi. So I'm going to go back to my code, my text file, my Word document, whatever I wanted it to save. Oh, come on. There we go. And so the area of a sphere is A equals 4 times, we got to put asterisks between all these things, or if you're writing it like grade schooler, you'd put a great big X there, but let's go ahead and use asterisks.
Wait,
and then let's call it pi.
In Python idle?
You can write this in anything you want, and then times r, and then how do you represent that? To the power of 2. Well, you may have learned to do that. How's about doing it like that? That means squared. And then go and Google up the formulas for the other 3. Right. So I'll paste this, copy and paste this into the assignment folder, so you don't necessarily have to type down the entire homework assignment. Doesn't hurt if you do. But we need to get out of here, so I'm going to make the Dropbox for this so that we can split. That's all you have to do.
What's the course key for the book?
I'm sorry, pardon me? Yeah. Reminder, there's no course key for the book. I know it sounds weird because when you buy MindTap or Cengage, it asks for it. But instead, over the weekend, I'm going to create the course inside Canvas, and then you're going to follow a link, and that's going to fill in the course key for you. I don't even have one when I do it that way. I'm not being stubborn. It's just that if I integrate it with Canvas, it doesn't give me one.
So this is what I was supposed to get, right?
Mm-hmm. You got it. And so we'll use that on Tuesday.
Check. And you're going to do something over the weekend so I can...
Yep, exactly. We'll do it on Tuesday.
Okay. At least I understand something.
Oh, I bet you understand a lot, and you're going to understand more and more as we go.
You have the PowerPoint already.
Yep, the PowerPoints you get to on modules, and that's what we're doing. Yep.
Adamantly, go over it.
Hurry up. People are waiting. All right, so what you're going to want to do is if you took notes, if you created a program, you're going to go to Modules, find the Lecture B folder. I'll do it with you, but this is going to be the last time I do it with you. I know most of y'all know how to do it. Whoopsie. Wrong, I wanted to choose View in Student Mode. And you already know how to do this. You don't have to be waiting for me to do it. But I'm going to go and click on Modules or Assignments, either way. Find Lecture B, click on it. If you typed in a program, when you submit it, go ahead and upload it. If you didn't, if you just want to say you were here, go to text entry instead, right? And you can type in I was here. Or you could do both, but I don't know why you'd do both.